Hey, hi everyone. Hello, how are you all doing? So, I am Manish Nehalani. Today we will be learning triangles. Yeah, triangles of grade 10. And it's lecture number 1 of triangles. So, it's just, I'll first tell you about myself. I am mathematics mentor at askIITians, and I have been teaching since past couple of years, and I have guided thousands of students for IIT-JEE mains and advance, and many students for Olympiads and KVPY as well. So today is most exciting class of triangles, and let's, without wasting any time, let's start triangles, right? Great. So I hope you all can see the screen, right? Correct. So let's begin now. You, as you all can see, that triangles is a very important chapter from your board's perspective, because this chapter is of 9 marks in boards. This chapter is of 9 marks in boards. So now with options, this comes for 9 marks. So now this is very important, because if you just do this one chapter, it fetches you 9 marks. Now you all can understand the importance of 9 marks in a board examination, right? So like and this chapter is almost like very simple, apart from construction. Like you all know that construction is a very simple chapter. It's a joyful chapter. We all have been enjoying that, to draw, take up a protractor, take up a rounder, and do all of that, and just play with the instruments. So this chapter is similar to that. This is from the geometry. This is very similar, but this is very simple chapter, like construction. So that is what this makes this chapter interesting and important. So let's quickly see what are the things which we are going to cover in today's class. So today we will be talking about similarity and congruency of triangles, similarity of triangles with geometrical figures, and similar polygons. So these are the things which we are going to talk about. Okay, so first let's understand why is it important to study similarity, right? What makes it important to study similarity? So you will say similarity helps in developing analytical thinking. So now, how does it help you in studying analytical thinking or in developing your analytical thinking? So you would say, and also it helps you to develop a perspective of comparison of two or more than two things. So for example, like the Burj Khalifa, right? It's like a triangular shaped structure, which is a very tall structure, right? And it has like 158 floors, right? And if you see, similarly, you have Eiffel Tower. So this is Burj Khalifa. This is in Dubai. And then you also have Eiffel Tower, right? Which is again a conical shaped curve. So now if you can see, now you all can similarly say Eiffel Tower is in Paris. Now you all can say that, okay, both are similar looking similar looking structures, right? So but they are not exactly same. So that is how it gives you a perspective of comparison, that they are not exactly same, they are different structures, but they are somewhat similar shape, somewhat of similar shape. So those structures, those things, those figures, those sketches which are of similar size, or rather similar shape but not similar size, not same size, are called as similar objects, right? So that is where we will be talking about similar objects have the same shape but not necessarily the same size. So this is what we need to understand, that these objects, if you look at these two triangles, triangle ABC and triangle GEF. So in this case, you can see that measure angle ABC and measure angle EGF, they both are equal. These both angles are equal. That is, measurement of angle ABC is equivalent to measurement of angle EGF, right? Or FGE in that case. And also we can see that these two pink Angles are also same, that is measure angle BAC is equal to measure angle GEF. Then similarly these two green angles, that is measure angle ACB is equal to measure angle EFG. Now you can clearly see that all three angles are similar, but what is the difference between these two triangles? That their length of sides are not same. That is, length of AB is not equal to length of GE, and this is same for other sides as well. So what do we conclude? We can clearly say that these objects have same angles, they have similar shape, they have same shape, but they don't have the same size. So this is what we call about similar objects. Now we would also be talking about congruent objects, right? So congruent objects have both same shape and same size. Now you can clearly see triangle ABC and triangle DEF. If you all can clearly see that length of AB is equal to length of DE here, right? Length of AB is equal to length of DE. Similarly, length of BC is equal to length of EF, and length of AC is equal to length of DF. So these all three corresponding sides. What do you mean by corresponding? Now these two triangles are looking similar. They are of same shape, right? Now what makes them unique is they are twins, right? ये दोनों जुड़वा है. अब हमें पता है कि जुड़वा क्या होता है. ठीक है. सो ये दोनों जुड़वा ट्रायंगल है. जो भी जुड़वा चीजें होंगी ना, वी विल कॉल देम एज कॉन्ग्रुएंट. अब जुड़वा जरूरी नहीं है, दे आर ऑलवेज टू. जुड़वा is twins, right? They did not be only two, they can be more than two as well. So more than two objects which are of exactly similar size and shape are called as congruent objects. So they have both same shape and same size, right? So this is what is the difference between similarity and congruency. So in this case we will say triangle ABC is congruent to triangle DEF, right? This is the symbol for congruency, right? This is the symbol for congruency. But in the previous case, we could say that triangle ABC is similar to triangle GEF. This is the symbol for similarity, right? This is what we need to understand, that what is the difference between similar objects and congruent objects. So I hope this difference is so far clear, and we can now move ahead to a couple of questions, right? Now comes every student says, sir, please some questions kara do please. So there comes a question now. So it says, is the figure below congruent? So you have two triangles, that is triangle ABC and triangle XYZ, right? Now he says, are these two triangles congruent? So you all can think of it, that is, here what is given, we are given length of AB is equal to length of XY, right? That is 10 centimeter. And also we are given one more thing, or other two more angles as equal, that is measurement of angle CAB is equal to measurement of angle XYZ is equal to 75 degrees. And also we have measure angle ACB is equal to measure angle XZY, which is equal to 65 degrees, right? So in this case we say these triangles which have same angles and same side length, therefore they have to be congruent, right? So triangle ABC is congruent to triangle XYZ as it has same shape and same size. The angle and the side are of same length, right, as seen here. So this is what is about congruency and similarity, right? So we now have a glimpse of what is similarity, we have an idea what is congruency, right? But there is a lot more to be seen. There are few more interesting things which we need to talk about, right? Like if you could just compare two random lines, random straight lines, if you just compare two random circles, what will happen? Are they similar? Are they congruent? Can they be congruent? Can they be similar? And a lot of that. So let's come to that. So now we'll talk about similarity with respect to geometrical figures. See, geometrical figures having same shape but different sizes are known as similar figures. So if they have the same shape but different sizes should be different, then they are similar figures, right? Because if the sizes are same, then they will be congruent, right? Then they will be congruent. So we are talking about similar figures in this. Like if you just look at the given figure, this is a figure of a, you can say, a rocket, right? A space rocket. So now you can see that this triangle is similar to this triangle, right? Because both of them are right angled triangles, right? So you will say triangle A is similar to triangle B, right? Now it could be congruent, but we don't know its length. We don't know its length. It could be congruent because it looks like congruent, right? Similarly, we can talk about triangle C and triangle D, right? So these are similarity with respect to geometrical figures. Now here you have all the geometrical figures, that is you are talking about a rectangle, square, circle, and a triangle as well, right? So let's quickly move ahead. Next we will be talking about similar polygons now. So what are similar polygons? Similar polygons have the same shape again but not the same size. So it says IE. What do you mean by IE, right? We all know IE means that is, है ना? अब that is को IE से क्यों लिखते हैं, TI से क्यों नहीं लिखते सर? बताओ. That is को IE से क्यों लिखते हैं? Why don't we not write it with TI? Anyone? Correct, correct. Why do we not write that is as IE and not as TI? Very good. So it's like when you talk about in Latin it was known as id est. So id est आप सभी ने Google कर लिया. Id est is the Latin meaning. But why do we write it in English? So it means idea exchange. So when you are writing a same idea in exchanged words, that is, here we were talking about same size, like similar polygons have the same shape but not the same size. So it was clear that it should not be of the same size, but we were writing the same idea in different words, in exchanged words, and those exchanged words are one is bigger than the other. So when we say one is bigger than the other, it clearly means that the other one has to be smaller than the previous one, right? So idea exchange, it's like that. So similar polygons have same shape but not the same size. So in that case we say idea exchange. That is, so two polygons are said to be similar if their corresponding angles are equal and the lengths of their corresponding sides are proportional, which means, first of all, we need to understand what do we mean by a polygon. So there are two types of polygon: open polygon and closed polygon, right? Open polygon and closed polygon. So first of all, a polygon means a figure with many sides, a figure with many sides. So open polygon and closed polygon means the polygon which has n sides but it is open. For example, like this, it is an open polygon. But when you talk about a closed polygon, it is like this, right? This is a closed polygon. So because all the vertices are connected to one another. So when we say about polygons, a polygon can be of n sides. So here when we say there are two polygons, so for example this is a pentagon, this is a 5-sided polygon, this is a pentagon, it is exactly similar, right? So these two pentagons are similar to each other because they have the same shape, because they are pentagons but not the same size. So we would say if the side of a pentagon are not same, we would say they are not congruent polygons, but they are similar polygons. So here we would say since it is a pentagon, their angles will also be equal. So if their corresponding angles are equal and the length of their sides are proportional, then we say two polygons are similar to each other. ठीक है, two polygons are similar to each other. So in this case we will say the angles should be equal but the sides can be proportional. What do you mean by proportional again? Proportional means they should be in the same ratio, right? They should be in the same ratio. For example, like again we have a question, but before that let's again understand the meaning of proportional. So for example, if you have two polygons, to be more precise, you have two triangles, one bada triangle and the other one is chota triangle. So triangle ABC and triangle DEF. Now in this case, if we say that the angle B is equal to angle E, right? Angle B is equal to angle B, and AB upon DE is equal to BC by EF, which means the lengths of sides are in proportional. The lengths of sides are proportional. Then in that case we say these two triangles are similar triangles. These two polygons are similar polygons, right? So angles should be equal. That is, measure angle B should be equal to measure angle E. But the sides need not be equal. The sides should be in same proportion, right? मतलब समझ रहे हो? मतलब if this is 6 then ये 3 है, तो ये भी होना चाहिए 2 and ये होना चाहिए 1, because 6 by 3 is equal to 2 upon 1. So sides same proportion में होने चाहिए. ठीक है? Now let's try to solve this question. ठीक है, अब आते हैं इस क्वेश्चन पे. ये क्या कह रहा है? Fill in the blanks. All dash triangles are similar. And उसने दो options दे दिए. So the two options which we have are isosceles triangle or equilateral triangle, right? So and the second one we have is all circles are dash congruent or similar. So let's try to first think of the first one. It says all dash triangles are similar. So are all isosceles triangles similar? First of all, what is an isosceles triangle? Isosceles triangles have two same sides, right? Two same sides, and if the sides are same, their angles are corresponding opposite angles are also same, right? तो ये होते हैं isosceles triangle. Whereas equilateral triangle में तो सभी angles and all the sides are same. So first we need to understand कि सारे isosceles triangles similar हैं क्या. So if this is one isosceles triangle and then we have another isosceles triangle like this, let's say this is DEF, right? And we need to understand whether these two triangles are will always be similar or not. This is what we need to understand, right? So triangle ABC and triangle DEF, will they be similar? What do you all think? Because see, what did we say? When will two polygons be similar? If their corresponding sides are in proportion and the angles are equal. So here the corresponding sides will always be in proportion. You will say no, because AB upon DE can be in proportion with AC upon DF, but they need not be in proportion with BC upon EF, right? They can't be in that proportion. So we would say all isosceles triangles need not necessarily be similar always, because सारे sides proportion में नहीं है, right? Although again, what could be the second reason for not being similar? You would say although angle B is equal to angle E and angle C could be equal to angle F, but do you think that angle A will also be equal to angle D? No, right? It is not necessarily same. That is why you would say all the angles are not equal. So that is why we would say in this case, अगर ये दोनों angles proportion में है, the third angle need not be in the equal. So in this case, we would say all isosceles triangles need not be similar. ठीक है? So first one, we would say therefore all equilateral triangles are similar, because all equilateral triangles have angles as 60 degrees and they have same congruent sides. So their sides will always be in proportion and their angles will always be equal, right? Let's move to next. Now we'll see this. Okay, this is the solution. So any two equilateral triangles are similar, any two circles are similar but not necessarily congruent, because you all can see here that is these two or these three different circles have different radii, although they have a common tangent. This is the common tangent of these circles, but they have different radii, right? They have different radii. So one is 2 units, 4 units and 8 units. So they are similar circles but not congruent circles. Similarly, when you talk about equilateral triangles, so if you know just one side of an equilateral triangle, you can say all other sides would be same. So here one side was 5, other sides were also 5. One side is 15, other sides will also be 15. So the sides will always be in proportion. 5 by 15 equals to 5 by 15 equals to 5 by 15. And also all angles will be equal, right? So therefore any two equilateral triangles are similar. This is a very important result. Any two equilateral triangles are similar, right? And as we saw, are all isosceles triangles similar? So we said no, all isosceles triangles are not similar for a couple of reasons. That is, the base of the triangle can stay same, but the base angles and lengths of two equal sides can change. So for the first reason, as we saw earlier, triangle ABC and triangle DEF, although both could be isosceles, but BC could be equal to EF, but do you really think that the other two sides will also be equal, or will they always be same? So we said no. And what was the second reason? The length of the two equal sides can stay the same, but the measure of angle between two equal sides will change, as will the base and the base angles, right? So this was for triangle GEF and triangle LMN, right? So length of two equal sides can stay same, but the measure of angle between the two equal sides will change, as will the base and base angles. So this is the two reasons. These are the two reasons, important reasons why we'll say that any two isosceles triangles are not always similar, right? Let's solve one more question. So it says in similar polygons, corresponding sides are dash and corresponding angles are dash. So it's like he's asking that corresponding sides are should always be equal or should always be in proportion, or how is it like? So as we said, sir, अभी अभी तो आपने बताया corresponding sides are always in proportion, that is they are proportional, and corresponding angles are always equal. The angles have to be equal, right? So this is about similarity and congruency. This is what we learned about and discussed. How do we differentiate similarity and congruency? And we would definitely learn new things and exciting things in the next class. Still then, stay safe, enjoy. Thank you very much.